Hi everyone, welcome to daily lead code problem challenge. So today problem is total characters in string after transformations first. So let me break down this problem and explain you. So let's say you are given a string, right? And the number of transformation is a t. And finally, you have to return the length of the final string. So it will be 7. Let me explain how it will be. So if we do the first transformation, so a becomes b, we have to increase the character here by one time. So a becomes b, becomes c. But for z, there is a different condition. We can see here, if the character is z, replace it with the string ab, right? So here there is no z, so we can simply increase the character by one, and the final string will be bcdzz. Now, if we do the second transformation of the output of the first transformation string, so b becomes c, similarly z becomes ab, again this, and the final string will be cdeabab, and the length of this final string is 7 characters, right? So the output will be 7. Now let's approach this problem. So the whenever you are approaching the problem, first think like in a brute force way, then go to the optimal, right? So in brute force way, what we can do, we can simply run the loop according to the transformation t, right? A number of transformation, we have to run two times loop and increase the character, and after that, yeah. So but when the transformation increases, right, we can see the constant here, t can be less than equal to 10 to the power 5. So when the t increases, the time complexity of the brute force approach increases. So this is not the optimal way, so let's think about the optimal way. So since we are we are given a string and it is a character, right? So we can think of some like hash map type solution. Let me explain you. So what we can do, we can create, like there are 26 characters in alphabet. So we can create 26 array, and inside each array, we can create t plus 1 length of array. For example, here let me show you. So here we can see, you can see here, you can see this is the array of 26 array, right? And this first one is t0 transformation, second one is t1, and first one is sorry, I mean the first one is minus t0 transformation, and this first transformation, and this is second transformation, right? So we have created an array of length 26, and inside each, for each character, we have created a transformation array, right? And we have initialized, let me walk you through the code and explain this solution. So here, okay. So here I have so here I have considered the total length is 0, since we have to return the total length, and I am running on each character of the string. I am running the loop on each character of string. So total length will be total length plus, and I have created this function. Inside this function, this is get length. Inside this function, I am passing two parameters. That is the character which I am getting from the iteration, and the transformation. This t, right? Transformation that is given in the problem. How many times we have to transform, and we are taking the modulo of this mod. So in question, it is it is explained, since answer can be very large, so we have to return it a modulo of 10 to the power 9 plus 7. So uh, we have defined the constant here modulo, and we are taking the modulo of the total length, right? And so now let's deep dive into this get length function, which is the main logic. So here I am taking the character and the remaining transformation as rem. So now for each character we have to take the index, right? So I have defined the separate function for that, which will convert character like a to 0, b to 1, right? So in JavaScript, you can simply do it like c.char coded 0 minus a dot char coded 0, right? So it will return the index. Like if we pass a, it will return 0. If we pass char to index b, it will return 1, right? And after that we have to define the base case scenario, like if the transformation is 0, let's say we already have transformed it, so in that case we have to return the 1, right? And one more thing, and we are using memoization concept here because we don't want to find for each character which is already been processed, right? So for example, we have defined memoization table. Here we can say, so here we have created a memo array that from length 26, and for each array we are creating array of t plus 1 and filling that with minus 1. So the output of this will be this. So that there is 26 array, and for each array we are creating an array of length t plus 1 and filling with minus 1, right? So the output will be this. And now what we are doing, we are basically checking in our this memoization table memo, if for index this and remaining this, right? If it is not equal to minus 1, if you are, I mean, this means if we already calculated this before, so if we calculated this before, then we have to return the cache value, else we will process the logic. So now we have considered variable late result, and we are checking, like we have two conditions: either character will be z or it will be any other character. So for z we have to consider different logic, because we are when we reach to z, then we try to increment that, then the next string will be ab, right? So we are applying a special rule for z. So here what we are doing, in result we are assigning, again we are calling it recursively, right? So we don't know, it, I mean, we are calling it recursively for z, because for z the final, for z the next string will be ab. So what we are doing, we are simply calling get length function recursively for a and for b, right? So we are calling it separate for get length a, and now the transformation will become, let's say we have called this get length as for like transformation 2. So now we are breaking it down, so now the transformation we will decrease by 1, right? So here we have decreased the remaining transformation as transformation minus 1 and this minus 1, right? And it will return the total length of this a and b. So that's why whenever we are returning length, we always have to take the modulo of that, so that the length will not be much bigger. So we are assigning it to result else. So let's say if the character is not z, for in that case what we are doing, we are basically taking the I mean char coded 0, and if we are incrementing 1, for example, let if there is b, so we are making it c, right? And we are taking the char from that, so we are taking the c as a string next char, okay? And again we are trying to run this recursively, call this get length recursively for the next character, okay? And now the transformation will become transformation minus 1. So this is the logic. So let me dry run it, and which will explain you clearly. So for example, let's say we have a string az, and the transcription we have to transform it two times. So let me run the dry run. So let's say we will be calling it get length a and transformation 2. So what it will do, it will simply call here, it will call again next character, which will be for a it will be b, as we are calculating the next character here, right? And remaining will become 1. So here we can see we are calling get length as b and 1. Now again it will increase, b will become c and 1 will become, if the transformation will decrease 0. So here we have written a base condition, if the remaining will be 0, so we have to return 1, and there will be no further transformation. So this will return 1, okay? Now again, this was for a, and now we will do for z. So for z we are running again. Yeah, for z we'll be passing transformation as 2, and the next of z will be, this will be special case right here. If c is equal to z, we'll be running this. So we'll be running for a and b separately, and we'll be adding that. So here you can see, for z, we are calling recursively get length, and again plus get length as a1 and b1. So again for a we are calling b, and transformation will become 0, so it will return 1. And for get length b1, since we already calculated b1 here, right? So now memoization comes into effect. So it will check like if b1 is there or not. So b1 is there, so it will not recalculate. So from this memoization, it will basically take from the cache. So it will take 1 from the cache, and 1 plus 1 will become 2, right? So here you can see the final 2 and plus 1, the final answer will be like 3. Okay. Okay. So now we have solved the problem, but we need to find the time and space complexity. Okay. So let's find that time and space complexity. So here you can see total time will be, since we are I mean we are filling the we are doing the memoization, so we are creating a table for that. So the time for that will be 26 into t. Sorry, I have written here t. And we are running loop as well, iterating through each character of string s. So for that, it will be big O of n. So final will be big O of n plus t. It will be time complexity. And for space complexity, we are using memoization table. So it will be like 26 into t plus 1. And here we are also using few helper variables, but it's fine. So the final space complexity will be big O of t, where n is the length of the original string and t is the number of transformation. Okay, so this is the time and space complexity. And let me submit it. Okay, so it is accepted here. And yeah, so it took 1695 millisecond. It's fine. Memory has this much MB. Okay, fine. Okay, so this is the solution for that. And if you liked it, please like and subscribe my channel, and let me know if you want any uh, further explanation or solution for any other lead code daily challenge problem. Thank you so much for watching.